Hello everyone. Hi, how are you? Today we are going to discuss about IPv4. This is the very basic topic if you are preparing for CCNA, if you are a network guy, if you are preparing for a job in a network field, then this is going to be the very basic topic to start network. To start anything in network, we need what? We need IP address. So let's discuss what is IP address and what is the IPv4 version of IP address. Okay. So in this small tutorial, what we are going to discuss is we are going to discuss about IPv4 and why we need a IP address. We are going to discuss what are the information we have about the IP address that we will going to discuss here, and what will be the structure of a IP address, how the structure of a IP address is made. We are going to discuss that also. And in the last, what we will be discussing is what are the classes we have in the IP address. Okay, so let's go in the next slide. Here you can see we are having different devices. Like we have a laptop, we have 3 PCs, we have a phone. So why this diagram I have made? So basically we are going to discuss why we need IP address. So what is the need of an IP address? If there somebody is asking a question, why we need an IP address? So generally, to communicate between two devices, what we need? We need some address. Suppose in the old days, what we were doing, we were sending one letter, one postcard. So before sending that, what we need? We need the we need the address of the destination where we are sending. Suppose a person sitting in Delhi is sending a postcard to Mumbai. How it is going to be delivered there? The very basic understanding is that we will write a address on the postcard, that to this address we need to deliver this message, this letter. So in the similar fashion, in this modern world, to communicate over the internet, everyone having will have a address, and that address we refer as IP address. I guess you are clear. So suppose I am having a PC in Mumbai and I want to communicate a PC in London. So how I am going to communicate? This is through IP address. Suppose this PC will have some IP 10 dot series. Okay, it can be 10 dot 10 dot 10 dot 10. So this device need an IP address. This device also needs an IP address. Then only they can communicate with each other through internet. So why we need IP address? Because to communicate with each other, a network device needs an IP address, and that IP address should be unique. Okay, so it means every devices which we have, your laptop, your phone, your iPad, your iPhone, whichever is communicating with internet, is having one unique IP address through which we are going to identify and we are communicating on this internet world. So no matter wherever you are sitting, London, New York, Mumbai, wherever you are sitting, it doesn't matter. What matters is your IP address. So network only understands the IP address. They don't understand where the location is. They don't understand these old days. What we have old days, we have addresses for sending the postcard. We have people, a guy sitting in Delhi wants to deliver a message to a guy sitting in Mumbai. What they need the IP address. But in the network, in the internet, what we need an IP address to which we want to deliver our message, we want to deliver our email, whatever communication we are doing, we need an IP address. Okay, let's move forward. Discuss what are the information we have. Let's discuss about the information about IP address. So these are the few information which we have about IP address. These are the very basic information about IP addresses. Internet Protocol version 4 is the fourth version of IP addresses. Okay, so this is the fourth version of IP address. Yes, we have IP v1, v2, v3 as well, but we don't use because of their limitations and they are outdated. 32-bit address divided into 4 octets. So IPv4 is divided into 32 bits, which will be in the form of 4 octets. So suppose we are having one IP address that will be divided into 4 octets. Okay, so first 8-bit will be in the first octet, second 8-bit here, third 8-bit here, fourth 8-bit here, and total we are going to having 32 bits. Okay, so this 32-bit IP addressing system is divided into 4 octets. Every network devices will have a unique IP address. As I told you on the earlier slide, to communicate over the internet you should have a unique IP address. Otherwise you won't be able to communicate over the internet. Total addresses in IPv4 are 42949679296. This is a long term. You can see this is the many addresses we are having available in the IPv4 version. So you can see this is a limited number of IP addresses, some 10,000, lakh, 10 lakh, crore, 10 crore, and other. So 4.2, you can say 429 crore IP addresses we are total having, and we know our world population is more than around 700 crore. So there is a limitation of IPv4. We are having only 420 crores of IP address, and in this modern world everyone is having multiple number of devices. Somebody is having 3 mobile phones, 2 desktop, and 2 laptops. So we are having different, and this number is increasing like anything, and people are using internet very fast in this network world. So at the time when IPv4 was developed, people were not aware that this much internet is going to be popular and this much we are going to use internet in the future. That's why we made a IPv4 version at that time. But now we have realized that this is going to be short, this is going to be end at some point of time. That's why we decided to switch over some different IP address, and we are in a progression to switch over IPv6, which will be of 128 bits. So this will have much more IP addresses than IPv4 we are having. So we will discuss about this also. Any network devices can communicate with only if they have an IP address. So this is very true. Yes, to communicate over the internet you need an IP address, otherwise you will be not able to communicate. So IP addresses are the basic addresses your device is having. To access internet one must have IP address. Yes, to access internet you must have an IP address, otherwise you will be not able to we will be not able to access the internet. IPv6, which is of 128 bits. So this IPv6 is come into the picture when this IPv4 gets short, and we are having, as you know, we are having limited number of IPv4 addresses, and the demand in the market is growing like anything. Everyone is having large number of devices, and the internet is reaching to the rural areas as well. So in future we will be going to use the IPv6. Implementation has started right now also. So there are some areas where we are using this IPv6 version, but as of now IPv4 is the only and the most popular protocol which we are using. Okay, so I hope we have a limited, and we have now much information about the IP address, what is an IP address, how it is divided and how it is made, what are the versions we have, what are the limitations of IPv4, and why we need IPv6 to communicate over internet. We need IP addresses. This all, I guess, it is clear till now. Let's move to the next slide. So in this slide we are going to discuss about the structure of IP address, how exactly an IP address is made, what is the structure of that, what all it constitutes of. We are going to see here, and let's see. IP addresses are 32 bits long. Yes, the IP address is a 32 bits long. These are the 32 bits. Okay, IP address are divided into 4 sections of 1 byte octet each. Yes, it is divided into 4 octets. First this one, second octet, third octet, and this is the fourth octet. So IP address are typically written in a format known as dotted decimal. Yes, this is the dotted decimal representation. When you are writing an IP address, what exactly you are writing? You will be writing like 10.34.216.75. So this is called the dotted decimal representation, and this is the binary representation of IP address. So why we use this dotted representation of an IP address? This is very simple, because these are very simple to learn, these are very simple to calculate. So for human readable, you can say these are human readable, these are machine readable. So we human beings are generally very easy and very comfortable when we are using these decimal numbers, and this is very easy to calculate, this is easy to remember, and there are so many advantages when you are using the decimal numbers. You are not going to remember these all 32 bits, and the calculations are very easy here. If you are using the decimal numbers, it is very easy understandable which subnet it is. If you are going to give these binary numbers, you generally will be not able to identify which subnet it belongs. So these are the all limitations. That's why we have made these binary numbers into the decimal numbers. But what exactly is going on? Suppose we have two electronic devices. How they are communicating? Are they communicating through decimal numbers? No, they will be communicating through binary numbers, because we know electronic devices only understand binaries, that is 1 or 0. So that's what is the IP address all about. When you are referring a device, suppose I am referring this device that this is 10.34.216.75, how another device is going to understand? They are going to understand what? They are going to understand 0 0 0 0 1 0 1 0. Like that it is going to understand that I have to go to this device. Okay, so what is this binary numbers? As you know, these electrical signals, if you have these electrical signals or electromagnetic signals, whatever you have, it is going to be converted into 0 and 1, which a machine, which a electronic device understands. Okay, so let's discuss one of the few IP addresses which we have. These 3 IP addresses we have. Let's discuss about 192.168.100.4. What is this? This is this much of binary numbers. Let's see what is here. This is 0 dot 0 dot, sorry, 0 0 0 0 0 1 0 0. So what is this? This is 2 to the power 2. That's why it is known as 4. Similar fashion, we have 100. This is equal to 2 to the power 7, 2 to the power 6, and 2 to the power 2. And this all going to constitute what we get, it is going to constitute 100. So what IP addresses is going to start? So the minimum range of IP addresses means the IP address from where it starts is, like if you have 0 dot 0, means if you have all the zeros in the first octet, second octet, third octet, fourth octet, in all octet if you are having 0, then what does it mean? It means 0. So the first IP address which can be, or the lowest IP address which can be, is 0 dot 0 dot 0 dot 0. Similarly, the highest number of, or the biggest IP address which we have, which IPv4 can have, is 255 dot 255 dot 255 dot 255 dot 255. So this is the largest IP address in IPv4, and 0 dot 0 dot 0 dot 0 is going to be smallest IP address in IPv4. So we learned how the structure is made of. To quick round up the structure, basically we have dotted decimal representation in the decimal numbers, and the structure consists of these binary bits which will be divided into 4 octets, and each octets is having 8 bits of number, and these 8 bits are nothing but the decimal. These are the binary representation of these decimal numbers which we have in the decimal dotted representation. So whenever you are referring on any IP address, whichever you are referring from this 255, sorry, from 0 to 255.255.255, these IP address are nothing but these are the binary numbers. Okay, so let's move on to the next slide and let's see what we have. So our next, in this section, what we are going to discuss, we are going to look generally very quick roundup. We are going to see what are the classes we have in the IP addresses, IPv4. So IPv4, as I told you, it is going to start from 0 and it is going to start to 255. Okay, so these 256 series of IP addresses, it will be in the form of .x, you can say. .x. So this series of IP addresses 0 to 255 series we have divided into 5 classes. Out of that 5 classes, first 3 classes we are using, and these are in use right now, and these 2 classes, this is for research purpose and this is a restricted class of IP addresses. So in class A series of IP address, we are going to have a IP address from 0 to 127 series. It means from 0.0.0.0 to 127.255.255.255. This is going to be the last IP in the class A addresses. Similar, we have the class B range of IP addresses, which is going to start from 128 series and it will end till the 191 series. The class C addresses starts from 192 series and ends till 223. Similarly, the class D address starts from 224 and it ends till 239, and the class E address, which is starts from 240, it ends till 255. These are the reserved purpose IP addresses. So nowadays, means IPv6 is going to come, because we have certain limitations. You can see only 3 classes of IP address we are using, and these IP addresses are around 420 crore, 29 crore something it is. So it is going to end someday. That's why we are going to implement IPv6. Let's discuss the next slide. In the next slide, what we are going to basically discuss, we are going to discuss 3 or 4 things here. First, what is the private IP address and what is the public IP address? So public IP addresses are paid. The IP addresses for which you are paying is called public IP addresses, and the IP address which is free for common use, which we are using, a common per person in using in laptop, are the free IP addresses. And the public IP addresses are generally used by the company organizations, different organizations and different companies, different sectors. They are using, they are paying for this. That's why they are having these IP addresses. And for the general and the free purpose of use, we have private IP addresses. So in each classes, we can see we have private IP address. This is the private IP address in class A, 10.series IP address. So any IP which you are seeing around you, 10.series is a private IP address and it belongs to class A IP address. Similarly, class B is having a IP address range called 172.16.0. So any address which is starting from 172.16, you are saying it is a class B and it is a private IP address. It is free. And in class C, we have 192.168 series. So this is the class C private address. Okay, so 3 private address range we use generally. We are having in IPv4 10.172.16, 192.168. 127.0.0.8. What is this? This is the loopback address. So what is this? This is used for testing the networks in your system, any devices. What is this 169.254.0.0? This range you will see on your computer when you are seeing a triangle marks at the network. It means you are not having a network. So this is called the link local APIPA. So basically you can say this is the APIPA IP address. So when you are not getting any network in your system, then link local IP addresses you will see in your system. This will be starting from the 169.254 range. This is known as locally known, you can say APIPA IP address. So as we know, we are using the 3 classes of IP address, A, B and C. This is the D class of IP address, 124.0.0.0. So it is used for IP multiclassed. This is in the D class of network address, and 240 series IP addresses are in the E class. You can say these are the reserved IP addresses. So what is this multicast address used for? Multicast address we use basically for multicasting the different protocols like RIP. We are having the multicast address of RIP 224.0.0.10. Similarly for EIGRP it's RIP it is 9, EIGRP it is 10. Okay. So these are the multicast addresses, and as you can see, this is the largest IP address which we have in the IPv4. Generally we refer it as a broadcast address. So any IP address, the end IP we will be generally referring to the broadcast end IP. Remember, if you are using a subnet, the end IP of that subnet will be broadcast address, and in that subnet the first IP will be the network address. Okay, so starting IP is the network address, the end IP is the broadcast address. And now let's see what is exactly this class A and class C is having. How many network addresses we have in class A and how many host addresses are there. In class B we can see around 16,000 network addresses are there and 65,000 host addresses are there. So how exactly this we are forming? So for a class A series, suppose we are having a network of 10 dot 10 dot 10 dot 10. So this first octet is called the network address and the last 3 octets are known as the host address. So that's why we can see in the class A range of IP addresses, host addresses can be this much, but network addresses will be this only. But in class C it is quite reverse, you can say. We have these much of network addresses, many numbers of subnets, and each subnet you are going to have 254 IP addresses and one network address and another broadcast address, to total 255 from 0 to 254, you can say. So I hope you like this all what we have discussed about IPv4. I hope you have understand a little bit about IPv4, what exactly IPv4 is all about, what is the structure of IP address, what are the different classifications inside the IPv4 addresses, what is broadcast, what is current network address, and what is public IP, what is the private IP, why we use IP address, what is the need of IP address. I hope these things are clear to you now. So thank you guys, thank you for watching this video. Please like and subscribe our channel, and if you have any query, please comment in the comment section so that we will answer. I will try to answer your questions. Thanks guys.